Hey guys, welcome back to Reignited and our Automotive Basics series. Now, in this video, we are covering engine diagnostics and more specifically, how to diagnose a misfire. This is one of those things where if you're new to automotive, it can be very frustrating to try to tackle and it's very easy to overthink it as well. I'm going to give you my perspective as a professional technician and my process of how exactly I narrow the issue down to find out what's going on with the misfire. Now in this video, I'm going to tailor it specifically to the Hemi engine, but the same process applies for pretty much any modern engine. Now, if you do have a Hemi powered vehicle, make sure you watch this video all the way to the end because I do have a special tip regarding a misfire that only affects the Hemi engines. Now, the reason I said the Hemi engine is a modern engine is because it has so many electronically controlled components. You have your coil-on plug ignition, you have drive-by-wire throttle body, you have fuel injection. That's what I mean by modern. And that being the case, you're going to need a few tools to help you diagnose it. Now, these are must-haves, non-negotiable. However, they are all very budget friendly. The first thing you're going to have is a basic code reader, some sort of OBD2 scanner. Now, you don't have to have one. This is a Matco brand. It's a glorified thing. I paid extra because it has that name on it. Realistically, you can get this exact same thing and a more modern one for between $20 and $30 through Amazon or something like that. They're not expensive. There's no excuse not to have one. And if you're serious about working on your car, it's an absolute must-have. Now, of course, when it comes to scan tools, more features is always better. So if you can afford a better scan tool, I would absolutely recommend doing so. In fact, when we're diagnosing a misfire here, if you have a scan tool that is capable of doing a misfire monitor, then that will absolutely make this whole process a whole lot easier. However, those are generally going to be a lot more expensive. So in this case, we're just keeping it simple with just your generic OBD2 scan tool that only covers your powertrain codes. Next item, we're going extremely cheap here with a digital multimeter. This is the one available from Harbor Freight. I think it's like $5, $10. I think they even have coupons where you can get this for free if you buy literally anything else. It is the cheapest multimeter I've ever seen, but it doesn't matter because it will accomplish the goal of what we're trying to do in our process of trying to diagnose our misfire. Now, last tool I would say is an absolute must-have for diagnosing a misfire is a compression tester, some sort of kit of some kind. Same story with these. There are so many kits available on Amazon for very, very cheap. It is inexcusable not to have one of these in your possession if you are serious about working on your car. So those are the three tools I would say are non-negotiable for trying to figure out what sort of misfire issue you're having on your car. All right, let's make the assumption that because you are trying to diagnose a misfire, this means that you already have a check engine light on in your car and you know that the engine is misfiring. One of the ways in which you can tell that your engine is misfiring is that that check engine light will be flashing while the engine is running because it's detecting a consistent misfire. If the misfire comes and goes, maybe that check engine light will remain on solid. So our first step in our diagnostic process is to really narrow down and figure out which exact cylinder it is that is misfiring. Hopefully you have a code in your car that will tell you which cylinder it is. Generally, these codes you're going to be looking at will start with a P030 something. So the very last number here of this code indicates which cylinder it is that is misfiring. So if it's P0301, obviously we're dealing with cylinder number 1. P0308, it's cylinder number 8. So very easy to distinguish that. Now, occasionally when you have a misfire and you look up the code, it'll give you a P0300. Now, what this is a multiple cylinder misfire. So it's saying, hey, it's happening on multiple cylinders. I can't quite tell exactly which one it is that's causing the issue. Now, P0300 is going to be an entirely different diagnostic process because if something is affecting multiple cylinders at once, chances are that it's not going to be an individual component within one of those cylinders. It's something that all of the cylinders have in common, and therefore it's affecting multiple cylinders. I would say the most often cause of a P0300 that I see is some sort of a fuel issue. Basically, it's not getting enough fuel, or it's getting bad fuel, like water in the fuel or something like that. But P0300 is going to be a different diagnostic process altogether. We are focusing in this video only on single cylinder misfires. Let's take a quick moment to segue and talk about how your engine even knows that a misfire is happening. Now, does it have some sort of a misfire sensor somewhere on the engine that could tell when a cylinder isn't firing? Well, yes and no. It is sensor based, but it's using a sensor that already has another task assigned to it. Now, would it interest you to know that your crankshaft is constantly speeding up and slowing down? Well, you might say, of course it is. My RPMs are going up, my RPMs are going down. That's not what I'm talking about though. I'm saying during every single revolution of your crankshaft inside the engine, it is constantly speeding up and slowing down. What's happening is as each cylinder is firing, it's igniting that mixture, it's on the power cycle, it pushes that piston down inside the cylinder. For that brief instant of time, your crankshaft will speed up, and the crankshaft position sensor can register that speed increase. And because of the PCM, it knows the timing of the engine and it knows which cylinder is firing when. Therefore, it's anticipating that crankshaft speeding up for each power cycle for each cylinder. If it doesn't see that speeding up of the crankshaft happen for when that cylinder fires, it then registers it as a misfire. It's actually really fascinating stuff. All right, let's say for the purposes of our demonstration that the code we have is a P0303 or cylinder number 3 misfire. Now the biggest issue I see with people is they automatically jump to the worst case scenario, especially when it comes to the Hemi engine. They automatically think, man, I've got a lifter issue here. This is gonna cost me thousands of dollars. Slow down. We can get to that, and it may come to that eventually, but rule out every other possibility first before you go that deep down the rabbit hole. The very first thing that we're going to do here is simple, easy checks to try to identify what our issue is or where exactly it's located. So the very first thing that I will do when I am diagnosing an issue that is in, let's say, cylinder number 3, is we're going to do some swapping of some parts. Very simply though, we're going to move the coil pack to a different cylinder. Let's say we're going to move it to cylinder number 5. And then we're going to take those spark plugs in cylinder number 3 and we're going to move those to cylinder number 1. And then after we do that, put everything back together again, we're going to clear the code, drive the vehicle again, and see if the misfire returns. And if it does, did that misfire stay in cylinder number 3, or did it jump to cylinder number 5 or to number 1? If it jumped to a different cylinder, automatically you know that that component that you shifted to that other cylinder is your issue and you don't need to go any farther. And sometimes it's as simple as that. So as you're moving the spark plugs to one cylinder and the coil pack to another cylinder, that is a great time to do a physical inspection of both of those components. Look at them up close, take a look at the spark plugs and make sure that there's not any sort of a crack in the porcelain. Make sure there's no physical damage to the ground strap on there, just anything like that. As far as the coil pack itself goes, just make sure that there's no torn boots or anything like that. Sometimes people are careless when they're working on these things and they can cause various issues like that. Now, one thing that's easy to think too is that, hey, this thing's got 2 spark plugs per cylinder, so even if I have one bad spark plug, that's not gonna cause a misfire on that cylinder. That is absolutely incorrect. If you do have even one bad spark plug on this cylinder, it will cause a misfire. Also, look at the connectors and the wiring going to them. Rodent damage is an extremely common problem within the automotive world. If you live in an area where you suspect that rodents could be an issue, I mean, basically, if you open the hood of your car and you smell kind of the urine smell that those rodents have, then you know that there could be a potential issue for that. They like to chew through those wires, and that could be a very simple fix. All right, let's say we performed step 1 and the misfire did not follow either the coil pack or the spark plugs. It stayed consistent with cylinder number 3. What is our next step? Now remember, the entire idea behind this video is to go from the easiest thing to the hardest thing. So moving along that line, the next thing we're going to check is going to be the fuel injector for the cylinder that is misfiring. Now what we're going to do is we're going to be checking resistance. So using the ohms function on a digital multimeter, we're just checking across the pins of that fuel injector and see what the resistance reading is. Now that number in isolation doesn't mean anything, so a good rule of thumb is to go ahead and check several fuel injectors on the cylinders that you know are working just fine, and that will give you a baseline to work off of. And then when you check the cylinder that is misfiring, you can tell if that number does not then match up. I will say that the resistance of these fuel injectors is temperature dependent. So if you check one at 30 degrees and one at 70 degrees, you're going to get a different reading out of it. So don't try to twist those numbers too much. I think if they're in the same general range, I think you're probably okay with your fuel injectors. What we're usually looking for is one that's way out of whack with the other ones, or is OL or open, meaning it does not actually have resistance between the terminals, which means that the solenoid is not working. Now, if you do this process and you're still unsure about the numbers you've gotten and you're just not sure if there might still be an issue, you can actually remove the fuel rail and go ahead and swap the injector from the cylinder that's misfiring to a different cylinder, again keeping track of where you actually put it, and then run it again and see if the misfire then follows that injector. So at this point, we've verified that it is not the coil pack, it is not the spark plugs, and it's not the fuel injector. Where do we go from here? Well, at this point is when I introduce the compression tester. Now, one thing to note about this is go ahead and pull the fuse for your fuel pump and then crank the engine over until it no longer fires on its own. You don't really want the engine firing up while you're doing a compression test. When you're doing this, obviously you only want to pull one spark plug from whatever cylinder it is that you are testing, and then screw this guy in there and crank the engine for between 5 to 8 seconds. Now, many people will tell you that when you're running a compression test, you want to have the throttle blade wide open to get an accurate result. And this is true. However, one thing to note is that you have a drive-by-wire setup on here, which means it is an electronically controlled throttle. And if you floor the throttle on one of those, it keeps it completely closed and goes into what's called a flood clear mode, so it doesn't work. So there's not really an effective way to hold that throttle open, and I also do not suggest sticking anything in the throttle to hold it open. That's also not good for it. What I will say is that the actual number that you are getting when you're performing the compression test does not need to be 100% accurate. Now, why exactly do I say that? Well, the reason I say that is because the number itself is somewhat immaterial. I would say if you have a number of above 130 PSI, the compression is fine. It's not going to be the source of your misfire issue. The only time you're going to notice on a compression test if you have a very serious issue is if you have less than 100 PSI in that particular cylinder. Anything less than 100 PSI in a cylinder after cranking, that's going to cause a misfire. So we're not looking for an exact number here. We're just looking for if it's above or below that threshold. Now, again, a good way to compare is to do multiple cylinders, get yourself a baseline, and then go to the one that is misfiring and see if there is a large variation there between that cylinder and all the other cylinders. Now, I will say generally on the Hemi engine, I see around 150 PSI per cylinder when I'm doing a compression test. Now, obviously there's a huge amount of factors that go into that can affect that number either positive or negatively, but around 150 PSI is what I would expect to see on a good, healthy engine. But again, if you're doing your testing and you're getting a consistent 130 PSI across all the cylinders, including the one that's misfiring, I'm going to say right now that the compression is not going to be your issue. Now, if you do run a test and you find that your compression numbers are below 100 PSI, what are the potential culprits for something like that? Well, generally, if you're still making some compression, but you're reading really low numbers, at that point, you'd be looking at a possible piston or piston ring issue where that air is really seeping past the sides of the piston and down into the crankcase itself. I wouldn't necessarily say that you're looking at a valve issue at that time, because generally any sort of a valve issue will lead you with way less than 100 PSI. You'll be down around 30 or even 0 PSI if you have, let's say, a bent valve, a drop valve seat, or a broken valve spring. But those are usually ones that you will notice a lot more with the drivability issues than just a standard misfire. And to be clear, I don't often see issues with the Hemi engine as far as having poor compression as a result of bad piston rings or a melted piston, anything like that. It is an extraordinarily rare event for these engines. All right, let's say you perform your compression test and the numbers have come back basically average among all the other cylinders, or maybe just a little bit below average. What is going to be our next step? Well, I'll say that this is when it starts to get a little bit more technical and some more specialized tools will be involved. Therefore, if you are just like a hobby mechanic, this is about when I would say you might want to start thinking about taking it to a shop to be professionally diagnosed. At this point, the very next step that I would perform would be a leak down test. So you can get a leak down tester, same as you can buy a compression tester. It is a little bit more technical to figure out, but it's not really that big of a deal. But if you are inclined on using that sort of thing, you can figure it out pretty simply. What a leak down tester does that a compression tester does not do is it basically checks your valves as far as how well they are seating inside the cylinder head. So if you have a slight leak with one of your valves, maybe it's slightly bent or there's a carbon buildup on there, something of that nature, you're going to get a leak through that valve seat. And that basically you'll have pressurized air within the cylinder itself, and that air will leak out of that valve seat, and you can actually hear it either coming out the intake or coming out the exhaust, and that kind of helps pinpoint where the issue lies. Now, to be perfectly clear, when you're using a leak down tester, there's always going to be a certain percentage of air that is going to force its way past the piston rings and down into the crankcase. So if you're seeing some air escape, I think the number is around like 11%, and you're thinking, oh man, I've got a problem. No, that is perfectly normal. But if you are seeing around 20 to 30% leak down, then you know for sure that you've got some sort of a valve sealing issue, and at that point you'll be pulling your cylinder head and sending off to a machine shop to be repaired. At this point, we've eliminated all of the simple options that it could be. let's say that we still have a P0303 cylinder number 3 misfire. We know it's not the coil pack, we know it's not the spark plugs, we know it's not the fuel injector, we know it's not our piston rings, and we know it's not a valve sealing issue within the cylinder head. But we still have a consistent misfire on cylinder number 3. Well, at that point, I hate to say it, but now we're probably looking at the possibility that you have a valve lifter failure. And the reason I say that is because once that lifter roller stops spinning, it starts eating into the lobe of the camshaft itself. And once it wears that lobe down far enough, it will no longer open the valve quite enough as necessary to allow for full combustion. And at that point, you're gonna have a misfire. Now, I will say that in all my years as a Chrysler technician, one of the things I have learned is that if it is a cam and lifter issue misfire, then generally that will show itself more under hard acceleration. Many times they won't misfire at all during idle, but when you really stomp on it, that's when the misfire shows itself. In fact, a great example of this, way back when, before we even knew that the cam and lifter was a thing, we were working on a police vehicle. I was working on a police Charger, and I was driving it around, and I couldn't get this thing to misfire at all. I didn't know what the guy was talking about. Now, as technicians, we're trained to drive these vehicles very gently. They're not our cars, right? So we're just gonna drive them around. They belong to somebody else. We're not gonna romp on these things. And I told the guy, I was like, hey, I can't get this thing to misfire. And finally, the cop actually contacted me and said, hey, no, you gotta stomp on this thing and act like you're chasing somebody. Sure enough, as soon as I did that, here's the misfire, bam, hard misfire in your face. And of course, it ended up being a cam and lifter issue. Now, once a cam and lifter issue progresses along far enough, it will misfire at all times, idle all the way through. Now, all the time I have people in my videos asking me, how can I make sure it's a lifter failure before actually tearing it all apart? And the answer is, you can't really. You actually have to remove the cylinder head, remove the lifter, and actually inspect that lifter roller to see if those needle bearings have failed, and then look down the lifter bore at the camshaft lobe and see if the lobe itself is damaged. Now remember, if you're going to be doing this yourself, you have to actually spin the camshaft so that the pointy section of the lobe is actually pointing at the lifter bore. Because if you're looking at the back side of the lobe, it's going to look perfectly fine no matter what. Even if the front side is really eaten away, the back side looks perfect. All right, so what was that special tip I talked about when it comes to Hemi engine and a misfire? Well, many times when you've done a major engine repair, say you've had to remove the cylinder heads to replace the lifters, you put everything back together again, you fire the engine up, and now you've got a misfire where you didn't have one before. Well, I would say 90% of the time, it's because you've had a push rod that has popped out of place or did not get fully seated correctly within the rocker arms. It is extraordinarily common, not just among hobby mechanics, but also among professional mechanics too, to make this exact same mistake. Pull your valve covers off, take a look at those push rods. I can almost guarantee you're gonna find your issue right there. So there it is. That is my process for diagnosing a misfire on a modern Hemi engine, or really any modern engine. Now, of course, there's always going to be more details, more things that can be added. But again, this is an automotive basics video, so I just wanted to hit the high points here. If you guys have a subject that you want me to cover in the next automotive basics video, go ahead and leave that in a comment down below.